Saxon Advanced Math Lesson 1.G is areas and sector circles. First thing is we have to remember what area is. Area will always end up with a square unit because, well, length times width is my area, right? And that's really simple. This is a very quick review over some of the plane geometric figures, finding the area. So area of a triangle, 1/2 base times height. Remember that sometimes height is used interchangeably with the word altitude. And that's why I did put that as an A up here. The next terminology we're going to talk about here is for a circle. For a circle, when we're working with these, I have to be able to label a couple of things with circle. First of all, radius and diameter, and those we already know. Those are not difficult. Some of the terms we will use throughout this book that may or may not be familiar with you, an arc. This is a little piece of a curve. If I look at it this way, this is arc. There's an arc. This arc is subtended by this radius and this radius. And that arc is part of the outside of the circle. That leaves me with a central angle right here, or this would be a central angle. Central angles are angles that are on the inside of the circle that the one vertex is the center of the circle itself. Now, when we're talking about area of a circle, almost all of you are going to recognize pi r squared and no problem. What we're going to be adding to that is finding the area of a sector. Now we have to first of all define what a sector is. A sector is a part of the circle that is a piece of pi of the total, if you want to think of it that way. Not pi as in 3.14, but like pi, like blueberry pie, right? So this is or pizza pie. It's this little slice of pizza. And when I'm talking about area, there's really no easy direct method to find the area of this sector without using the total circle. So the radiuses, these are straight lines. That would be simple. We could get almost a triangle out of that if we have one more, but we don't. We have one side that's an arc. And this arc, because as the circle gets larger, that arc changes shape, right? The bigger the circle gets, the more closely it resembles a straight line. So the only way to find the area of this sector is to relate it to the area of the whole circle. Now, we already know how to find the area of the whole circle. So if I did a really simple example and said, let's find the area of this sector right here. And most of you are going to recognize right off the bat that if that's a 90 degree, that is 1/4 of the circle. 1/4 of the circle. If I knew the whole area of the circle, well, the area of the circle is pi r squared, so 64 pi, 1/4 would give me 16 pi. And it's really that simple. Now, for us as students of math and working with this, it may not be as quick and easy to do that because not always is it a nice 1/4 amount. And I put that up here easier than the book example on my right up here because I wanted you to see how simple this concept is. If I went through it mathematically and worked it out, I would say I want 90 degrees of the 360 degrees that the complete circle holds. Well, how much area is the complete circle? 64 pi, right? 8 squared pi. So when I'm looking at the area of the whole circle, I'm going to multiply that by 90 over 360. If it makes more sense to you to think this way, I'm taking my 64 pi and I'm breaking it into 360 tiny little pieces all the way around the circle. And then I'm multiplying back 90 of them, and that's how much that is from here to here. It just happens to be equal to 1/4 in this case. Let's look at example 1.1, and this will make more sense as we work with this mathematically for you. I've got an area that we want me to find, which is this sector here. Notice this is a major arc instead of a minor arc that we're looking with on this one. They said the radius is 2√5, and this angle is, central angle is 126. Well, if this is 126, I need to find the angle from here to here. Well, the easiest way to do that is to realize that 360 degrees is all the way around. So I say 360 minus 126, which is 234. So it's 234 degrees this way around on the circle. I don't want the area of the whole thing. I want 236 of the 234 of the 360 pieces. So I write 234 of the 360 pieces. That's the area I want. Of what? The total. Well, what is the total? Pi r squared. 2√5 squared times pi times 234 over 360. The easiest way to do this, 2√5 times 2√5 is 4 times 5, right? 2 times 2 is 4, and √5 times √5 is 5. 4 times 5 is 20. I went ahead and put the whole thing over it so you can see how easy this was. 20 times 234 divided by 360, and that's going to give me 13 pi. If you don't believe me, check that on the calculator. It does work out. It's really simple. Two things that I want you to recognize in going forward in this book. One of them is it's almost always acceptable to leave the answer in terms of pi. And the reason why is 13 pi is much more exact than its equivalency, or very close equivalency, of 40.84. If you use your calculator and you make sure it's in degrees, or else your pi will be messed up, and you say 13 times pi, you're not going to get 40.84. You're going to get 40.84 and a decimal that continues until your calculator cuts it off. Not very exact. Because where do we round that? Where if I say it's 13 pi, that is an exact answer. And many times in the book, you will hear the words, find the exact answer, or leave in terms of pi. And that's what we're going to do on this one, 13 pi. I put in there 40.84 because that's what that is. If you were to work that out, put it on this calculator just like you see, but that's going to have a rounded value. Either way is acceptable on quizzes and tests, at least in my class. However, unless the book tells you find the exact answer. This is much cleaner of a way of writing it, and that's why I would suggest using their method of 13 pi.